The thousands and thousands of types that are in the .NET framework are all organized into namespaces. You can think of them as bins where types get placed into to give them a logical organization. For example, if you look at types that are defined inside of the system.net namespace, you'll find types that are related to network communications. So socket types and things to deal with TCP IP addresses and DNS lookups. Namespaces also help us avoid type name collisions. That's where I create a class called customer and you create a class called customer, and it turns out we can still use those easily inside of the same application as long as we put those in different namespaces. You can define your namespaces for your types in one or more places, and the way you do that is by using that namespace keyword that we saw here. So that in this example, program is inside of the namespace Hello World VS. int32 is a built-in type. It's actually in the system namespace. And there's two ways that we can refer to this type int32. If we want to declare a variable of type int32 and we do not have a using clause here, you'll notice that we get errors for int32 and console. All of a sudden the C# compiler doesn't know what these things are. We could tell it we want a system.int32 and a system.console. Now it knows exactly what types we're dealing with. We can build and still get a successful compilation. What this using keyword is really doing is telling the C# compiler, go ahead and look through all of the types that are defined inside of the system namespace when you're trying to resolve what an int32 is. So we don't need to include system.console.writeLine. We can just say system, or we can just say console.writeLine and int32. Many times, particularly when you're creating configuration files, you have to deal with what we call fully qualified type names. A fully qualified type name includes all of the information that the CLR needs to locate a type. That includes not just the type name, like int32, but also the namespace that that type is inside of, and the assembly where the code for that type lives. Let's take a look at an example. Let me take this result, and what we're going to do is write out the fully qualified type name of int32. Actually, what we're going to do is we're going to walk up to result, and there's a method on every object in .NET called getType. We're going to invoke getType, and that gives us back the type information for that object. And one of the things we can look at in the type information is the assembly qualified name. That's the same as the fully qualified name of this type. We're going to write that out. So let's do a build. Every time we change a program, we want to make sure we do a build. And let's run the application. And the fully qualified type name is system.int32, so that's namespace, the type name, and here's the assembly, mscorelib. So on disk somewhere there is an mscorelib.dll, and this is what we call a strongly named assembly because it has a version. It can be picked up for a specific culture, and it's cryptographically signed so that we know it's not tampered with. So the assembly name includes a public key token. We can use that to verify the integrity of that assembly. And as I mentioned before, there is a using directive. This brings a namespace into scope so that when we're using a type like int32, we don't have to namespace qualify it. We don't have to say system.int32. We can just say int32. So it's going to be quite common at the beginning of each of your .cs files, you're going to have a number of using keywords that bring namespaces into scope that you're going to be using inside of the code that's in that file. And these could be namespaces that are defined by the .NET Framework class library. There could also be namespaces for classes and types that you have defined that perhaps are in the same project, but maybe they're even in a different project, a different assembly. And it could also be other third parties.